Cool. Hello, and welcome to another Pachyderm webinar. My name is Chris, and I'm excited to welcome you all today. We have a great session lined up, and before we get started, I'd like to go over a few housekeeping items. If you have any video or audio issues while watching today's webinar, please try refreshing your window or browser. Today's webinar is being recorded, and we will share the recording after the webinar. In addition, if you have any questions for the presenters, be sure to use the Q&A widget on your screen. If we don't get to your question today, feel free to reach out to the presenters directly or post your question in the Pachyderm Slack channel. Today's presentation is titled Practical Data-Centric AI in the Real World. And with that, I'll pass it over to Fabiana and to Dan to begin the presentation.
Okay. Hi, everyone. Great to have you all here today. I'm Fabiana, Chief Data Officer at YData, and also one of the founding members of the Data-Centric AI Community. And I have here with me Dan Jeffries, the Chief Technical Evangelist at Pachyderm, and also Managing Director of AI Infrastructure Alliance, to talk us through what is practical data-centric AI. Hi, Dan.
How are you doing? I'm happy to be here with you. Let's have
Yeah.
some fun today.
Yes, for sure. And happy to be again on a webinar, especially around the topic that it's so dear to us. And maybe we can kick off with exactly with that. What is for you data-centric AI, or how would you describe it, to be honest?
I mean, we talk about this a bit in the presentation. I think we all know Andrew Ng's thinking about this, and but for me, data-centric AI is threatening to like surge into like buzzword without meaning, and I think it has. I think it actually has real meaning, right? In other words, but it has to be something that guides how people do things in the real world,
Mm-hmm.
right? And
Mm-hmm.
so oftentimes we kind of see sort of vague proclamations of data-centric AI, right? And but there's actually no steps that anybody can actually take to do it, or what does it mean, right? It's a bit like, it's a bit like saying the word God, right? It's like a Muslim, an atheist, a Christian, a Buddhist, they all hear something different, but we all think we're talking about the same thing. So if we
Join
level
this
set,
movement
yeah,
and
yeah,
it will
yeah,
be great. Yeah.
yeah, right. It's like, but it's totally different, right? Really, data-centric AI is about focusing on the data itself and solving the problems there. And,
Mm-hmm.
and when we
Mm-hmm.
look at the vast history of artificial intelligence, it's all been focused around the model. If there's a problem in the data's noisy. If there's missing pieces of the data, make the model better, change the model, tweak the hyperparameters, do all of the work there. And the model, it was sort of assumed that the data would just be imported. It would be perfect. It's like Boston
Yeah.
housing prices, right? And then you just go and it's already perfectly done. But the real world doesn't work like that. You're pulling data from 10 different
Yeah.
sources, enriching it, flipping it around, running it through a transcoder, whatever. Like there's 20 different things that need to happen. And then from that standpoint, there's also noisy data and data that needs to be
Yeah.
imputed. It's missing all this kind of stuff, right? It needs to be transformed into another format. There's tons of these things that need to be done. So it's really
Yeah.
a focus back on where we end up spending 90% of the time anyway. And that to me is really what data-centric AI is.
That's interesting, especially one of the things that you mentioned. Like, of course, we have this concept of garbage in, garbage out for quite some time. We all heard about it, but we also hear a lot of the assumption that if you iterate the model, the problems that the data has will just go away, or sometimes or somehow will be mitigated by the model itself. So I do sense that we have here two different paradigms. So for the ones that are hearing us, how do you describe or how do you compare themselves? So side by side, the biggest difference between both of them.
I mean, we've got a good chart with that right in here, right?
Yeah.
And if we look at that, and that came from Andrew Ng's model-centric, a chat with Andrew was one of the slides in there, so I credit Andrew with it. But I thought it was a good example of, in model-centric, you
Mm-hmm.
work on the code as your central objective. In data-centric, you're working on the data as the central objective, right? You're in the model, you're optimizing the model so it can deal with the noise. But in the data-centric, you don't just gather more data, you try to fix the noise in the data itself, right?
Yeah.
If the labels are off, in a model-centric, you try to work around it and assume that some of the data are screwy. In the data-centric, you go back and clarify your instructions and fix the labels, right? So it's really, I actually think it's more of a data engineering focused approach to things. If you look at like, and it can help bring in kind of a lot of IT folks, programmers, the people who would have been outside of kind of data science, right? Other than as kind of the IT infrastructure providers to the data scientists, right? And you know, at Pachyderm, there's an example. I think it was a live person where the infrastructure folks were, you know, using Pachyderm to kind of process all of the audio, you know, transcribe it, and they were doing it all in parallel. It took like something like seven weeks to process all the new audio that would come in, and with Pachyderm, they will do it in 7 hours or so. And what was that was a huge kind of move that allowed, but basically it was a handoff, right? And then the data scientists would do what they do with it. They'd be looking for features and iterating on the models and all that, but they kind of missed that whole part. I think data-centric AI is kind of unifying these two aspects of things. It's getting those teams to work closer together. It's getting them to creatively think about the problems together, and to not see it as something where you just, oh, well, we process the audio, we throw it over the fence to the data scientist, and the data scientists are like, cool, I don't know what that is. That's a black box to me. I assume the data is correct, and I'm just going to then iterate on the model. No, I think there has to be as these teams grow, as AI grows in the real world, just like we saw with DevOps and Agile and everything else, where you start to see these crossover teams where you need to know a little about programming, you need to know a little bit about, you know, systems infrastructure. You need to know a number of different kind of tool sets to do things, and you have to have this interdisciplinary thinking to solve these problems. I think that's where this is going as these kind of teams grow. This cross-disciplinary approach to solving problems.
Okay, so in this sense, then what it happens is not that, in your opinion, we will see that much the positions or the definition of what is a data science changing, but rather the way the teams relate and interact between each other. Is that correct?
Yeah, that's absolutely correct, right? I still think that there's kind of differing skill sets that are hard to have in a single person when you build a large team. If you're putting thousands of models into production, it's one thing to hire a single data scientist, throw a laptop at them, and go do some AI magic. You know, it's kind of nonsense. It's the same way it's nonsense in traditional coding in IT. Like there's always a joke in IT where, you know there's a downturn in the economy when they're looking for someone who's like, you know, a master Cisco engineer plus a Kubernetes infrastructure backend plus they know 6 languages and they can code in low-level C and they can do desktop support. And you're like, this person doesn't exist, right? And so there are discrete levels of skills, right? I mean, your math is always going to be better than mine. Your understanding of like looking at algorithms and how they work is always going to be better than mine. But my ability to like look at a brand new tool, a brand new system, abstract out how it works at a functional level, stand it up, make it work, and deliver it, you know, to you so that you can kind of play with the algorithms. Those are 2 different skill sets, but I believe that they're complementary. And as teams grow, you got to break down the walls and allow these teams to work together a lot more closely in order to solve problems in the real world.
It sounds like in the end we are like doing the same path software engineering suffered a few years ago, but now we are doing the same at the ML space. Like there is this need of defining the relations between what is an ML engineer, what is a data scientist, what is a data engineer, how do they relate with each other, and at each and every step of the AI development.
Everything else, you know, everything old is new again, right? I mean, like the patterns, the abstract patterns of how we do things repeat over time, right? If you look at, you know, the concept of an abstract data factory, for instance, which is like, if you look at software development, it's like, first we figure out how to do something in a really janky fashion, and then we refine it, then we start to abstract it up, and then we start to abstract the abstraction, right? There's like a pattern that develops over time. So that's how you get to Kubernetes, for instance, right? Kubernetes is a platform that allows you to run any kind of distributed application. It doesn't need to know what kind of application you need to run. Whereas if you go back in time a little bit to something like Spark, Spark is very specific, right? And now, you know, we look at Spark and a lot of folks, wow, that's an AI platform. No, it's a big data platform that's pivoted to AI. And it was designed to process data. And so it does that at scale really, really well, but mostly structured data. But it's you can't go throw a reinforcement learning on top of that, right? You can't, you're not going to come outside of the MapReduce framework. But Kubernetes was a further level of abstraction, right? You could process data at scale inside of Kubernetes, right? Or you could build a distributed web application or a reinforcement learning application because you abstracted the abstraction. Right? And so these kind of patterns happen again and again. And the history rhymes, it doesn't perfectly repeat. So in other words, you can't just take DevOps and port it over or whatever and go, bam, we've solved all the problems in artificial intelligence, right? But there's a level of like, and I talk about this coming up here, kind of these these sort of six keys, I think, to predictive data-centric AI in the real world.
Yeah, and that's exactly what I wanted to touch again as the next. For you, in practical senses, what are the changes or what are the adoptions that definitely the organizations or the teams should do in order to be more data-centric AI? Which goes to these 6 points.
Yeah, so these 6 points are really it, right? It's creative thinking, and I'll define what all these are. Well, we could talk about them, but it's like, it's creative thinking, it's synthetic data, it's data augmentation, it's a new set of tooling, it's a new type of testing, and it's also clarifying instructions. We'll look at each one, but like what's creative thinking, we've already kind of touched on a little bit differently, but it means that you're gonna have to think about the problems differently, right? And that it means kind of each problem requires a unique creative solution, and it involves a different set of skills, right, than data science skills, right? You may need an IT person, you may need an audio engineer, or a programmer, or a graphics designer. So let's take a good example there. Let's say that I'm trying to create a model that can pick out audio in the car and pick out commands in the car, and I find that the model's really struggling with noise in the background, but I just don't have enough samples of that noise. Maybe I've got some wind, an occasional radio in the background, maybe the kids shouting, but I don't have enough samples of that. Now, the typical way that you're going to solve that is just try to make the algorithm smarter at dealing with background noise, filtering the noise better, right? Coming up with a way to just segment it based on the hertz or whatever it is, right? And only listen to this narrow band where humans are speaking. But in the creative thinking process, you would solve it potentially in a different way, and it opens up new possibilities. I could go take a bunch of samples. So there's all kinds of open source samples in commercial libraries of background noise. I could go grab a bunch of music from somewhere on everyone's MP3 playlist. I could grab a bunch of background noise of kids shouting, and I could synthetically create those data sets, right? I could do that by just taking all the samples that I have and cloning them and using an audio engineer to just put some samples in the background and then have a programmer team basically automate the process, right? So that it's like, okay, now I've got a ton of these different samples. They're the same samples. Now I've got a ton of samples with a bunch of background noise, the kids saying like, are we there yet? Are we there yet? Like a bunch of music, a bunch of wind patterns, these kinds of things. And now I'm working, I might still tweak the algorithm. I may still, tweak type framers or change what I'm doing or try to refine it, but probably I'm not a research team coming up with, can I come up with something completely different to like only focus on this, this hertz. And so I'm probably working with the state of the art that's already kind of based on things that I'm kind of consuming. I'm a second level sort of, data science. I'm consuming the stuff that comes out of DeepMind and OpenAI and, Ian Goodfellow and whatever they're thinking up, right? And I'm not necessarily writing my own new stuff. And there's maybe another tier over that's kind of able to write some of the stuff, but mostly we're not. We're going to be just taking a lot of different models that we've got, right? We're going to read the papers, we're going to grok them, we're going to implement them in code. And so solving it is almost unrealistic for many teams out there at that level. But solving it with audio engineering and programming or whatever, that's, I think, within the skill set of a vast chunk of teams, and it's totally untapped. It's totally untapped, and it shouldn't be.
Yeah. So essentially adopt a more resourceful thinking around how to solve a problem rather than how can I use a model to overcome this. That's essentially the message, right? So regardless of what is the problem, there are many solutions, and we just have to go for the ones that we are able to deliver in the end.
You need to have a brainstorming session at the
Yeah.
beginning. Let's put down 50 crazy ideas or 10 crazy ideas. Let's whittle them down, right? And go, wait a
Yeah.
minute, these are like they're going to take, be totally open at the beginning, right?
Yeah.
Adopt a creative mindset of these things where you've got a ton of different ideas, and then you're going to go through and you're going to whittle them down and go, wait a minute, this is super resource intensive, this isn't going to work, whatever. But you're going to hit upon 3 or 4 different ways to kind of solve these things. I think teams are going to need to get a lot better at this over the next decade. Even if they don't know it yet, it's going to happen naturally.
Yeah.
That folks are going to have to learn to solve these problems in a unique way, and that's just one example. There's many different examples of how you could go and think about this kind of creatively of fixing the data and tweaking the model simultaneously. And I think that kind of
yeah. No, I was just saying that for that thinking and for that to happen, definitely the liability of the data responsibility to get it in a good shape kind of stretches to other areas than just the data science, and making the organization more open towards these questions. How it is the data? How can the teams be more interdisciplinary? That I think it's key, right?
That's absolutely the key, and I think like the faster we get there, kind of the better we are, right? And I already showed the kind of that model in the decks. We'll just kind of move past it, but it's in this kind of just kind of the same. It's all in the slides, so you get the slides later. But I won't just read through the stuff, right? We've already kind of talked about this, like in terms of the auto engineering or whatever. But what's interesting about the example that we already used is I kind of have already hinted at 2 other things, right? I've already hinted at synthetic data in data augmentation, which are the next kind of 2 steps, and they're different things, right? One is is synthetic data itself, right? And you and I've talked a lot about this offline, and then the new report that's coming out from the AI Infrastructure Alliance, kind of covering all of the industry and the ecosystem, its maturity, its capabilities. It's going to be very exciting. Everyone's going to be reading this in a few months. It's going to come out in late June or July. But the synthetic data, right? There's kind of a couple of ways to approach it, and one of the things that's interesting is we look at things like computer vision or audio, where they've been able to leverage tools, for instance, that came out of video games and audio engineering and film, right? And we got so good at being able to do this that now we can actually generate novel synthetic data in many aspects of this, right? And that's exciting. So for instance, if we can go back to our audio example, that's really wholly synthetic data, because we're grabbing a bunch of samples and we're making new ones, right? And we're combining things, but that's really synthetic. We're inventing the background noise, and it doesn't even need to be 100% perfect. But there's other examples of, if I wanted to create an algorithm that's good at detecting boat crashes, I probably couldn't realistically gather enough data of boat crashes over, it would be a time problem, the amount of time that it would take to gather that data. And I just probably wouldn't get enough of it, because there's generally good boat safety, and that's great. And we don't want to be, we don't want to be encouraging more boat crashes just to get data, right? So, but theoretically, and you look at some of the visual engines that have come out of this, Unity and a lot of these other engines that are out there, they could generate, with animators, essentially, boats crashing in lots of different ways. That's wholly synthetic data, and that can really be a game changer in terms of how we think about, some of these problems. And I know you probably have a lot to say on this subject, since that's sort of what you folks do.
But you touched on one thing I really would like to emphasize, which is sometimes the synthetic data produced just needs to be good enough, because you are dealing with cases that you just don't have many, or you have none, but you have to start somewhere. The key, or I think that the point that sometimes might be harder for the teams to understand how synthetic data can help them, is exactly that. when needs or when can I live with the good enough? And that goes to the point as well you mentioned. So there are several situations, boat crashes, you have hurricanes, you have the predictions of, I don't know, very rare events such as earthquakes, where maybe we don't have the real data. The real data is pretty rare, but you can do something with something else external or something produced synthetically, right?
Yeah, manufacturing is one of the ones that jumps to mind, right? One
Exactly.
of the
Yeah.
things
Yeah.
that Andrew's most focused on, right, is that you don't. I mean, his entire company is focused around the manufacturing side, and
Yeah.
there's good reason that his great brain thought about that. It's if I have whatever widget I'm producing, if I have an equal number of broken widgets, then I'm a pretty terrible manufacturer, right? In other words, like I should
Exactly.
not have I should not have a lot of samples of like misstitched shirts or smashed glass bottles, whatever it is I'm manufacturing, solar
Yeah.
panels. In fact, we look at that a little bit later, right?
Yeah.
And so I'm going to have to generate a lot of that data synthetically, right? In order for that to be something that, in order to be able to even have enough references, in order to be able to do something interesting with that data, right? Because there's just,
Yeah.
again, there's time infeasibility. We used to talk about computational infeasibility and encryption, right? Meaning, like, theoretically, if you had all the processing power in the world and a futuristic quantum computer, you could run the calculations long enough to break this code. But
Yeah.
actually, based on today's world and the amount of computing power we have, you can't, right? And so
Yeah.
the same sort of thing here is it's a time infeasibility, right? And that you're not going to be able to get enough broken widgets, I guess, unless you go send your people to the floor and start breaking them, right?
Exactly.
It's right. But again, that's time consuming too, right? And then you're
Yes.
hiring a photographer and all these kinds of things to do this. So this is where synthetic data really becomes interesting. And there are some limitations to different sides of it, right? I mean, in whether we can always generate a novel condition or those kinds of things. But again, as the synthetic data is only going to kind of increase over the coming years, and its ability to kind of kind of invent the world, if you will, is only going to get better.
Yeah. And well, I guess I have to agree definitely. And the fact that we see reports even from organizations such as Gartner exactly stating that synthetic data is probably one of the next big things, I guess it proves exactly the point you're sharing here today.
Right. We just saw Anthem, I think, putting down like, a big, press release and talk about how much they were
Yeah.
planning to use it for, for fraud. And that's a big, big company kind of looking at these kinds of things. So,
Exactly.
but then look, this kind of gets us to number 3 too, is it doesn't always need to have, the resources of generating synthetic data or getting familiar with those libraries or having a set of animators or whatever. You might just need some simple data augmentation. I know this, I do think, just starts to fall into kind of classical data science skills, right? I tend to use visual examples, but again, this applies to structured data, textual data, visual data, any kind of data, right? And the simple example is I can build more instances by kind of flipping the car around, right? So
Yeah.
the model learns to kind of see it from a few different angles. I might be able to do, like we were talking about with synthetic data, some of the things that are more possible with structured data is feeding in the data, getting the features from it, right? And then generating a lookalike data set, or generating more instances, right, of
Yeah.
things that I'm sort of short on, right? But again, it's data augmentation in terms of like these kind of basic techniques that I think people need to get better with as well in order to level up their skill set.
Yeah. I definitely, I do think that anyway, this is a skill that is, as you mentioned, more and more commoditized in terms of the data science based skill set, let's say. But definitely in computer vision, it's far more easy to understand the benefits of it. We can see it right away, or we can perceive it, I guess.
Visually, you can look at it, right? It's like,
Exactly.
right,
Exactly.
like I can look at this and go, all right, and I understand. I have two versions of a car, right? But
Exactly.
it doesn't mean there's no value in it outside of the structured data or in terms of lots of rows in the database or fraud example, right? If again, I've only got 30 different examples of the kinds of fraud I want to detect. That's still not enough data points. I probably want to generate slight variations of that, right? Or kind of flip it around in order to give the model more to kind of sink its teeth into. Right? So these kinds of things are crucial.
Yeah.
And then you're right that it's commoditized, but it's something that, again, people are just going to have to continue to get better at and assume that it extends out to a lot of different things.
Yeah, sure.
So look, let's move on to the fourth one here is the tools, right? The problem is that most of the tooling, and this is going to be kind of, I think, somewhat clear in the AI report. This is not a bad thing. It's just the way that the world has developed is that 80% of the tools have been focused on experimentation to model deployment and monitoring, right?
Yeah.
And that's because of the way that we've been doing this. And even if we're spending, 40, 50, 60% of our time in the data, side of the house, the tools weren't necessarily there. There are some tools, that are around for it. But really, having tools that are able to go through and manipulate these types of things is totally essential. And again, the vast majority are focused on that data experimentation. It's assuming the data is clean. Most of the tools are like, import the data once, it's fixed, and you're going to keep it. But there's really no focus on the wrangling, the cleaning, transforming, the augmentation stage, right? You'd have to write your own code to do it. And so, and the other kinds of things you're going to see, we talked about this with Pachyderm. Pachyderm is able to do a couple of things. One is it's able to do complex data transformations. And that's because it has decoupled logic. This is super critical to understand. If you look at something like Airflow, you look at something like Flight, you look at something like ZenML, you look at all these tools, great tools, fantastic tools, Prefect, all these tools are useful. The thing is, they're monolithic orchestrators, okay? They have to think of all the different ways that you might push, pull, drag, flip data, right? All those different things. And they have to bake that into the pipeline. They have a few different ways that you can kind of extend it if they didn't think of it. Airflow has, you can kind of write your own Python code, but they kind of want you to have a second skill set, which is like packaging it into a library. And it's not very robust, right? So really, you can't color outside the lines. That's the challenge with these kinds of things, right? Pachyderm's logic is totally decoupled, okay? And that means that at each step along the way, you define the data comes in and then there's a transformation step. And that transformation step is running in a container. I can put any kind of code in there that I want. If I want to write a bash script to flip all those images around, I can do that. If I want to write C code, if I want to write Rust, if I want to write some Python, I can do that. I can version it. And so there's that decoupled logic where Pachyderm and these kind of tools really excel is when there's a complex data transformation, you got to pull data from 5 different sources and enrich it. If you could just do, for instance, if you could just do a SQL query with dbt and run it and do everything with joins in your Snowflake, you don't need Pachyderm, you don't need data engineering, right? Yeah. But if you need to pull it out of Snowflake, grab data from Redshift, pull in sensor data from 5 other places, enrich the data, add 5 fields, and push it back in there, okay? That's where those complex transformations are. And those monolithic tool sets, by the way, totally useful for orchestrating a lot of these kind of these stagnant steps, data IQ, and all these kinds of things. All these are useful in practice, but having these sort of decoupled logic where you can basically think up anything, and we go back to that example from earlier, where if I wanted to transform, the audio, I want to go and write a bunch of code to kind of take my samples, grab a set of samples, feed them together with the things that I have. And maybe one of the steps is I've got to transcode the audio from WAV to MP4. And there's a C library out there that could do it super easily. It makes no sense to rewrite that in my own Python code. That's ridiculous, total waste of time. But with Pachyderm, I can grab that library, put it in a container, write some wrapper code around it, execute it, let it do its thing, and that's one step. Now it's gone from WAV to MP3. Now I write the next set of code that's taking all my background samples and iterating through them and putting out and doing an output at the end. So again, you're going to need language agnostic tools. You're going to need some decoupled logic, and you're going to need the ability to have really flexible data-centric pipelines. These types of things largely have not been the focus of data science teams and even the focus of data science purchasing. Again, almost 100% of that thing has been on experimentation and the interface behind it. And I think this really is going to have to change for people to do data-centric AI programs.
But this goes back again to the point we shared at the beginning around the teams, right? The multidisciplinary teams. they nowadays don't have a tool where they can be together. This is about having that tool, right?
Yeah, you've got to have and each team may need different sets of tools. That's
Yeah,
fine. That
exactly.
you can't think of anyone who tells you that they've got the end-to-end data science platform is like selling you a bridge. I'm sorry.
Yeah.
Look, there are many folks in the AI Infrastructure Alliance, in full disclosure, who have many aspects of that end-to-end, and depending on what you're doing, right? If you're doing kind of like, if you need some auto ML where you can throw 100 different things, that pre-existing at it, Data
Hmm.
Robot's going to have that thing for you. They're fantastic at these kinds of things. So this is not to take away from any of these tools that sort of say that there's an end to end, but
Hmm.
where that end to end tends to be is really like ingest data from some different sources, do some basic cleaning and those kinds of things, and then really get to the experimentation, usually at a structured level, and kind of a visualization, citizen data scientist kind of thing.
Yeah.
These are totally useful, but your team may need Figma. It may need it may need Audacity. It may need an audio editing tool. It may need Pachyderm to do the data-centric AI. It may need Prefect to kind of help orchestrate some of those things, and then Pachyderm can even run Prefect core in a container as one of the steps, right? In order to do kind of that transformation. Then you're not rewriting the code. You're just calling Prefect as one of the steps inside of Pachyderm. So it's going to necessarily need different tool sets. And again, when we talk
Yeah.
about the openness of the team, we need the openness of the organization to understand that this isn't a case of like the market hasn't matured enough to the point where like nobody ever got fired for buying IBM, like in the old days, or nobody ever got fired for buying Microsoft and Intel. We're not there yet where there's like the
Yeah.
one platform to do 90,000 things. We're going to need a best of breed solution to all of these things. You're going to need to trust your teams to give them the tools that they need.
Yeah. Totally.
Um, and then the last thing I'll kind of talk on, and this is sort of part and parcel to versioning and lineage. Versioning and
Hmm.
lineage, it is something where as you're iterating on the data sets, you're going to keep more track of them. And I think teams are going to learn this even more. Sometimes, honestly, if I'm being 100%, sometimes when we talk about data versioning and lineage, it's a late stage problem for where data scientists are a lot of the times today, right? And
Yes.
by the time they realize this problem, they're like, oh my god, this is horrible, right? Like 3 months later, a regulator comes in and is like, well, we don't like the data that you used. You violated XYZ health policy or like XYZ policy. You got to go back and strip all that data out of the model. And they're like, oh, oops, like we've already iterated on that data 12 times. And like they're in trouble. They're like straight up in
Yeah.
trouble. Like we're talking about existential level event trouble, right? We're talking about like getting fined trouble, but it's not just that kind of level of trouble. It's just sort of if you can't go back to the model in the code and recreate the thing that you did. If I've got a million JPEGs in a directory, and I go ahead and like and I, as the IT person, come in there and then crunch them down from 1024 by 768 to 512 by 512, and I overwrite them. Guess what? Your model may not perform as well, and there's nothing you can do about it
Exactly.
unless you're going to the backup. So having these iterations, especially as now I'm pushing and pulling the data, adding new samples, right? And what you don't want is this crap of like, well, we're gonna clone the directory 50 times and call it unknown version 6 and unknown 456, and now I'm gonna know what's in that data. You want something that's able to track the lineage and able to understand this
Hmm.
model in this set of code at this point in time with this exact data set. You want it to be deduplicated. Pachyderm's got a copy on write file system that does this. Some other tools are doing this too, mostly with copying it.
Yeah.
That works okay for structured data, but the problem is if you got a 1 gig video files and you're making 35 copies of those, I hope you have a lot more money in your Amazon bill. So having deduplicated versions where you've only changed 5 bits, that's super useful. So these kinds
Yeah.
of things, again, the tool set is going to become important as people think about these things. And the problem is coming like a hurricane, but people they don't see it yet until they start to kind of move in this direction. So I think we've gone into a lot of that. So I'm going to go right into 5 here, right?
Yeah.
And this is another thing that we're kind of stealing from the past, right? And things that already work in today's traditional programming houses and all this, building test and iteration tests, unit
Hmm.
tests, smoke tests, all these kinds of things, but with kind of the data. right, itself, right? Like there's been changes to the data and then the model started performing poorly, or we ingested a bunch of synthetic data. Again, better hope you have versioning because you just trained it 5 times and wait a minute, the synthetic data, it's an imprecise science at sometimes, right? Where maybe you like generated a bunch of samples that didn't work right? Or didn't affect model accuracy. You got to go back. If you happen to go to the backup tapes, like it's 1985, right? Like, or like then you're in big trouble, right? So you've got to make sure that you're writing these unit tests at each stage that kind of understands data quality. I know that you guys have got a ton of like focus on sort of data quality and things like that at this point. This is super important, right? Do you even know how many kind of examples you have, over-representation, under-representation? Do you have a test built in for these kinds of things? Can you test for it? When new data gets added, do you understand the implications of these kinds of things? You're going to have to start building unit tests like a real kind of like IT, developing team.
Exactly. Thinking about the question you want to see answer and try to test again and again, just to ensure that you are achieving the quality you are expecting, for sure.
Right. Human in the loop test, each stage of your development process.
Exactly.
These things are totally important too. Like, look, we'll talk about this, right? Let's look at the labeling example again. I use a lot of visual examples in here because text is boring to look at. But remember, all these techniques apply to structured data as easily as unstructured data, right? But let's say I've got this labeling platform, right? And I've got Snorkel, or I've got Scale, and they've got terrific data scientists. A lot of their value in their platforms is not the fact that they can just manually, get a bunch of people together and do a bunch of things. You can do those things with a lot of different platforms. Their thing is they've got a lot of data scientists that are building these semi-supervised learning systems that can kind of like help you quickly kind of auto label a lot of stuff. But sometimes those things are really noisy or they don't do them really well, right? That's one thing. So maybe you've got an instance segment, auto generator where you're like, okay, like it's gonna auto magically put a bounding box around what it thinks are like errors or flaws in this panel, right? Or we can think about it in the case of the humans. They might have said, we put the instructions down and they go, look, go put a bounding box around any of the flaws in this. And you've got 30 different, people working on it, or 150 people, or 1,000 people working on it. And they all hear those instructions and interpret them a little bit differently. And so, you might not get exactly what you want. And so the example kind of becomes back to this human in the loop testing is you've got to have a system that's able to kind of look at the data at different points to understand whether the labels are correct, for instance, or whether you've got additional points that actually make sense. And you may actually want to highlight all these little flaws that are in there that you could see in the second panel, right? And or maybe, again, this is where your domain expertise comes in. You may say, you know what, we don't care about those because they don't really affect the performance all that much. Maybe these little dots, I don't know much about solar panels, but maybe you do out there, right? And maybe that these 6 or 7 dots that I've highlighted here maybe add up to like a half a percentage point degradation. That's not enough to kick the panel off the line, but these big ones matter. Or maybe these things do a lot more damage. Maybe it makes it 3 or 5 or 7% less efficient, right? So you got to bring in that domain knowledge, and then that kind of like you've got to go back and unify those kinds of things. If you look at something like Superbia, they've got an example on their site of like the human in the loop test where they go and look at all the labels, they overlay them automatically on all the thing, right? And it goes, oh, there's a 98% crossover. Okay, well, we're going to go talk to the 2% of folks who do that, and we're going to help like change our instructions. And this is kind of, we'll get to this in just a second, but the one thing I want to emphasize to people is your job is not to go, well, the people who did this are geniuses and everyone who did this is an idiot, right? And like they just don't understand what I'm talking about here. No, that's not the way to approach it, right? When there's a deviance between kind of the two, the correct answer is to say what did we explain poorly to the folks who are doing this work, and how can we fix that? So we'll get to that in a second.
Exactly.
So this example here is like another one kind of snagged from our boy Andrew, like the reason for being. And but if thank you Andrew for this wonderful data slide. But like again, this is an example of look, the bounding boxes being different. We're put bounding boxes around an iguana. So like any human could reasonably interpret it in any of these three ways that he's kind of shown here, right? And so which one do you actually mean? In the same way that I showed here, what do
Yeah.
I mean by thing? And I need to go back and clarify my instructions to folks and refine those down to the point that I get what I want out of it. And again, that's a new iteration. You want a version of that, and you want feedback as you kind of go through these different things, and you understand what's happening, right?
Exactly.
And this, there's the slide from our wonderful
The
folks at Superb,
consensus.
right? Yeah, this is
Exactly.
the consensus,
Yeah.
right? It shows like, oh, but it shows like, okay, and then there's a QA process like that says, wait a minute, this is an issue over here. Like labeler one put this, I mean, I hope no labeler does this, but humans are capable of anything. They put it randomly around the fish, whereas this one kind of covers the entire fish, right? And you want to be able to approve or reject it, and you probably want some programming ability to do that, right?
Exactly. Yeah, totally.
So look, we'll sum this up here, and then let's get to some audience questions, right? I think is really, in the future of AI, look, we've always thought of ML code as the cool part of the data science. And in many ways, really it is. Let's just be honest, right? It's like the biggest breakthroughs we hear AlphaFold coming out, and all of a sudden now we can do all kinds of new bioscience and things that just were previously impossible. That's super cool, right? When we see a new reinforcement learning algorithm come out, and suddenly like we've got robots that are multifunctional, and they're like, I can't wait to have one that's cleaning my house, and these kinds of things, right? So look, these there's all kinds of these breakthroughs, but look, most teams are not research teams. Okay, they're not. They don't have people on there that are writing their own algorithms. They have people who are really, really smart and go read the most cutting edge papers on archive. They can stay up to date. They can implement that in code. They can put it in there. But the truth is, they're probably not going to be writing their own stuff that's going to improve on that. And so actually the algorithm is really a small component of the overall system. In fact, I think we've gotten to the point, because of so much focus on it, that many ways that the algorithms are very refined for a huge chunk of tasks. It doesn't mean for everything, right? There are problems you can't solve with today's algorithms, no question about it.
Yeah.
But the question is your team going to be able to come up with that algorithm that can solve it? And the answer is probably not. Is OpenAI or DeepMind or like 10 other like research teams out there, is you're probably going to be consuming a foundation model that they've come up with, or a paper they've come up with later on down the line if the problem's unsolvable. But if you're working on neural translate now, or you're working on fraud detection, if you're working on object detection, whatever, these are in many ways solved problems. It doesn't mean they're perfectly solved problems, but they're many ways solved problems with the algorithm. But you're not going to go and update the algorithm. You're going to basically focus on making that data set better, verifying it, transforming it, augmenting, adding to it with synthetic data, and that makes your feature extraction better, right? It makes the overall process better, and it unifies your team, right? To me, this is 100% the future of AI. And again, 60 to 70% AI complexity is bound to the data processing, that monitoring, augmentation, the handling. The data-centric guy is really just focusing back where we spend most of our time anyway, right?
Exactly.
Right? And stop pretending, that we're all Ian Goodfellow. We're not. I'm certainly not. And I'm not going to like come up with a game. I mean, Ian talked. I'm going to segue here. This is hilarious. Ian talked about a point where he had. It's not hilarious. The story what happened, but when he had he thought he was going to die at one point when he was very young, right? And he called up his friend and he brain dumped all of the ideas he had about artificial intelligence, because he wanted to make sure he got them down to someone before he died. I'm telling you right now, if I am dying tomorrow, the first thing I'm not doing is calling my friend to tell about, all of my ideas about AI. I'm not that good, and most of the people out there are not that good. Okay, so leave it to Ian and everyone else to come up with that stuff, and you worry about getting good with synthetic data and data processing and versioning and lineage and all this good stuff, and you're gonna do some amazing stuff out there. So thanks.
I guess it's all about the trade-offs and knowing your limitations and know where to invest your time, because in the end it's all about time and money, and where you will get the bigger stake. And I guess, as you mentioned, majority of the time we are anyways doing data preparation. Why not just invest a bit more on the tooling space for exactly that? Yeah, that's a very interesting point.
That's right. And I think we had a question there, right, on the data-centric AI and how to, how does it improve tabular data analysis, right? I think we did talk a bit about it during the meet, but Fabiana, you've got some good ideas about. I mean, with the synthetic data, maybe talk about it from that angle. Actually, that's probably useful.
Definitely. And I think there are two angles for this question that should be covered, because at one stage, one of the points that we see that could be improved around tabular data is first get the right understanding of your data. So a lot of the times we do kind of assume, as you mentioned, that the structured data, because it seems so clean, everything is fine, and we don't pay enough attention around getting inconsistencies, for example. So it's more or less some of the things you mentioned around this presentation, as you said, goes back to the side of tabular data. So first, get your exploratory data analysis, get your profiling of your data standardized around different teams, help really go in depth into your data. So adopt standardized ways, adopt tools to do that for your data science team. And afterwards, well, I'll be a bit repetitive in that sense. Adopt new methods to help you overcome those issues. Synthetic data is one of them. Data augmentation for sure. And again, data quality here will depend a lot on the use case that you have. So be specific on the question that you want to see answered. Be clear to everyone that's the question you want to see answered as well. So all the points that Dan mentioned today, all the six of them, I do think can easily apply for the tabular data in a nutshell.
All of them can, absolutely. Like, you know, right? I mean,
Yeah,
if we look at, I mean, look at an example of unit tests, right? Let's imagine that I've got
exactly.
a bunch of customer data with like APIs in there. Now, unlike a visual example, I'm not going to go look at it and understand whether my 75 character API key is in the correct format. But I can write heuristics. Again, I don't need something
Exactly.
super fancy. I don't need an ML model to go test my whether my API field conforms to the correct standard. I can write some heuristics just like we do with like looking at credit card data forms or whatever for, hey, is this actually the correct number of numbers in letters? Does it have characters in it that are wrong? These kinds of things. Understanding that kind of thing, building those tests in. Are there missing fields, for instance? Writing tests for those kinds of things. Are there fields that like where the half of the data is missing or whatever? Should I
Exactly.
impute that data? Those kinds of things.
Exactly.
All of these things can be applied to tabular data as well. Again, in a presentation, it's sort of boring to look at the tabular ones, but a lot of times we live in tabular data land, and so I like to use the visual examples in the presentations because it's, again, easier for us to look at, right? Again, if I put up 10 different API strings, we're not going to be able to look at that, and we
Exactly.
could write the code to do it, but rest assured, every one of these things applies to, how am I going to go and do it? If I were thinking about fraud detection, I mean, I might go and think about how to iterate on the different aspects of fraud that are out there, right? I might go
Even
and
around the labels, that's a good
right,
example, the one you gave. So different
that's right.
persons, different analysts see fraud in a different ways. They do have different manner of labeling the data. I saw this in the past also with, for example, smart meters. Different persons do different labels for the windowing, for example, on the time series data. How can you achieve consistency? How can you analyze that? What are your expectations for the business? So that goes to your point then, for sure.
Right, and look, every piece of data is labeled in some way, but obviously there's simpler sets of algorithms where, the labels are implied, for instance, right? In other
Yeah,
words, like if I'm looking
yeah,
at, whether the customer clicked or not, that's an implied, it's either yes or no, it's binary, right? And that's in there. So the labeling at that case is not going to make any difference, right? But the unit tests in terms of cleaning the data, understanding like whether those are actually correct, right? Building heuristics around that, building, there are lots of little pieces there, right, that can still be incredibly useful in terms of data. Does that mean that every single problem is going to fall to a data-centric AI approach? Of course not, right? We're not. It's not a panacea to every single problem. I'm not saying like here's your hammer, and like
yeah.
it also acts as a screwdriver, right? But
Exactly.
I want folks to just open up their minds and think about things in kind of a a fresh way, and understand that they may be missing a lot of good solutions to the challenges that they've never seen so far.
It's not like all of a sudden hyperparameter tuning stops being important. It's not about that. It's just about investing a bit more in something that have been missing, I guess. That's definitely it. I think so.
That's exactly it. That's exactly it. It's focusing in on, your data engineers and everyone else is just as important as the data scientists, and even more so getting them talking to each other. I mean, maybe we have to go back to those old offices where they tear down the walls and everyone codes on VBEX. I hope not. I always hated that personally. I like my own space. But for tearing down the virtual wall, yeah, that's just the engineer side, right? I'm like, dude, just leave me alone for 2 weeks so I can do what I need to do here. I don't want to beanbag. I don't want to code with like rock music on. But tearing down those walls virtually and allowing people to kind of work together in a cross-functional way, super important.
Yeah.
So do we have? I don't know. Do we have any other questions? You and I could probably talk for an hour and a half, but at the same time, I think we can always kind of wrap or kind of open it up to folks if they've got sort of give people a second chance in here if there's anything they're thinking of. I hope that you learned something, enjoyed something. Again, talk is going to be available after the after the fact. I think a ton of people end up watching these things after the fact. Now we're all busy, and the COVID has changed the way we consume information. So if you missed it today, we're still going to have one that you're going to be able to download and use, and hopefully it's going to give people insights that they just were missing.
Yeah, for sure. And well, just like we heard you today, I guess if, of course, you have always one more shot to ask a question. If not, we are eager anyways to hear your definition of what is data-centric AI at the Data-Centric AI community. So if after this session you now are more clear and you'd like to give us your opinion, well, feel free to submit at contest.datacentricai.community. We are eager to hear you.
Awesome. Hey, come and make sure you're in the Data-Centric AI community. You're probably already in here if you're already on the webinar. If you're not, then be there. That's one of the newest communities inside of the AI Infrastructure Alliance. We're kind of a community of communities, and we'd love to have your help if you're out there working in data engineering, data science. By the way, on the IA, especially on the board of data science, where we're doing some really cool projects. But we thanks everyone for their time. It was most appreciated, and we hope you had a wonderful day.
Thank you.